Welcome to the Cosmic Wonders series. Today, we're putting on our detective hats and becoming cosmic investigators. Our mission? To solve a case about something that's totally invisible, unbelievably powerful, and honestly, one of the biggest mysteries in the entire universe: the black hole. So, let's kick off our investigation with a little riddle. What's completely invisible but has more gravitational power than a million suns put together? Yep, you guessed it. It's a black hole, and our case is just getting started.
You know, every good investigation starts with profiling the suspect. So first things first, let's figure out what a black hole actually is.
Okay, so here's the deal. A black hole is basically a place where gravity has gone completely, well, off the charts. Just try to imagine taking a giant star, all that stuff, all that matter, and squishing it down into a space smaller than a single city. The gravity gets so incredibly intense that it creates this cosmic trap that nothing, and I mean nothing, can get out of, not even light itself.
Now, every black hole has this invisible boundary around it. It's called the event horizon. It's not like a wall you could go up and touch or anything. Think of it more like the edge of a giant cosmic waterfall. Once you cross that line, there is absolutely no turning back. It's the ultimate point of no return.
So now that we have a profile on our suspect, it's time to check out the lineup. And it turns out black holes come in all sorts of sizes, from the really small to the mind-bogglingly huge. On one end of the lineup, you've got black holes that could be as small as a single atom. But get this, they still have the mass of a giant mountain squeezed inside. Then, on the other end, you have the supermassive ones. These are the heavyweights, weighing more than 1,000,000 of our suns combined. They're the cosmic anchors sitting right in the middle of galaxies, including our own. And right in between those two extremes, you'll find the most common kind: stellar black holes. These guys can be up to 20 times more massive than our sun. They're what's left over after a truly giant star runs out of fuel and collapses in a massive explosion called a supernova. And this isn't just something happening in faraway galaxies. We've got one right in our own cosmic backyard. The supermassive black hole at the center of our Milky Way is called Sagittarius A star, and it has the mass of 4 million suns. It's a pretty powerful reminder of just how massive these things can get. So this all leads to a really big question for our investigation, right? If black holes are truly black, totally invisible, how in the world do our cosmic detectives, the scientists and astronomers, even know that they're out there? Well, just like any good detective, they follow the clues. The first clue? They see stars way out in space that look like they're orbiting absolutely nothing. That's a huge giveaway. The second clue is they can see this glowing, super hot gas swirling around the invisible object like water going down a drain. Third, they notice how its powerful gravity actually bends and distorts the light from stars behind it. And the last clue is really cool. They can literally feel ripples in the universe. When two black holes smash into each other, they create these waves in space-time that we can actually detect right here on Earth. All right, we know what they are, we know how to find them. Now it's time to close the case on some of the biggest myths you've probably heard about black holes. Okay, this one is probably the biggest myth out there. This idea that black holes are like giant, hungry vacuum cleaners, just roaming around the universe and sucking up everything that gets in their way. But here's the thing, that's not how they work at all. Black holes don't suck. They have gravity, just like a planet or a star. If you're far enough away from one, you would just orbit it. It's only when you get really, really close to that event horizon that you can't escape. Here's a great way to think about it. Let's pretend our sun magically disappeared and was replaced by a black hole with the exact same mass. What would happen to Earth? Well, we wouldn't fall in. We'd actually keep orbiting it, just like we orbit the sun right now. Sure, it would get really, really cold, but our planet's path in space wouldn't change. And that brings us to the most important fact of all. You can relax, because Earth is perfectly safe. There are no black holes anywhere near our solar system that could ever be a danger to us, so no need to worry. Okay, with the myths officially busted, it's time for the final reveal. Let's look at some of the weirdest, most mind-bending facts our investigation has uncovered about black holes. You're gonna love this one: spaghettification. And yes, that is a real scientific term. If something gets too close to a black hole, the gravity pulling on the side closer to it is so much stronger than the gravity pulling on the far side that the object gets stretched out, thinner and thinner, just like a piece of spaghetti.
Wild, right?
Black holes don't just sit there either, they spin. And some of them spin unbelievably fast. In fact, the fastest one we've ever found rotates more than 1,000 times every single second. Just try to wrap your head around that for a moment.
And finally, let's just talk about sheer scale. The smallest black holes we've actually observed are still almost 4 times the mass of our sun. Our own galaxy's black holes, Sagittarius A star, is 4 million times the mass of the sun. But the biggest one ever found, it's a staggering 66 billion times the mass of our sun. The range is just mind-boggling. So, our investigation has turned up a lot of clues, but you know what? The case is far from closed, which leaves us with one last big question. What other secrets are these cosmic mysteries still hiding from us in the dark? The search for answers continues. Thank you for listening to this Cosmic Wonders episode.